Okay, next up, we're gonna have the halogens. Okay, halogens are actually your group 7 elements. So group 1 elements, we name them alkali metals. Group 7 elements, we're gonna name them halogens. Okay, so what's about the halogens? What do we need to know? At the end, same thing, we need to know about the physical properties and the chemical properties. And next up, we need to predict the properties. In order to predict, what must you do? You must know the trend. Okay, so to predict, you must know the trend. First, you must describe, later you must predict. Okay, now, group 7 elements, okay, they are non-metals and they exist as diatomic covalent molecules. What does diatomic means? It means two atoms combined, two atoms bonded together. Okay, in this case here, what kind of bonding occurs between these two atoms? As you can see, covalent bonding. So your group 7 elements, they are non-metals that exist as diatomic covalent molecules. That means that all of them, okay, they have their formula looks like this. F2. This is the molecule of fluorine. Two fluorine bonded together by a covalent bond. Same thing, chlorine. In real life, it exists as a molecule with Cl2, Br2, iodine I2, astatine At2. So all of these elements in real life, they exist as diatomic covalent molecules. Okay, next up, what else do we know? They react with metals to form salts. Okay, they form salts. So example, sodium plus chlorine. What I'm going to have is NaCl, sodium chloride. So balance it, you get 2 sodium reacting with 1 chlorine molecule gives you 2 sodium chloride. So this is how they react metal to form salts. And we know that they are known as the halogens. Their ions are known as the halides. So you can see chlorine, example, chlorine, okay, when react sodium chloride. Okay, so this is known as sodium chloride. So the ion of the halogen is known as a halide because there's a IDE at the back. So that's how the IDE come about, because halogens, the ions are known as halides. So fluoride, chloride, bromide, iodide, astatite. Okay, astatite. Now, this is one interesting physical property here. Okay, at room temperature, chlorine is a yellowish greenish gas. Okay, as you can see from this picture here, bromine is a reddish brown liquid. Okay, you can see some of the reddish brown vapor here because bromine is a volatile. Okay, volatile liquid. Volatile means low melting and boiling point. Low melting point and boiling point. So that's why you can see that some of the liquid is actually forming vapors over here. Next one, iodine, purplish black solid. As you can see, there's also some purple vapor over here. Why? Once again, volatile. So because they are volatile substances, okay, they tend to vaporize. They vaporize quite easily. So iodine crystals is one of them, bromine liquid is another one. They tend to form vapors very easily. The main thing here is actually not about the vapor, but take note of the color. Okay, and also the state. Chlorine is in period 3, bromine is in period 4, iodine is in period 5. As it goes down the period, you should be starting to observe a trend here. Okay, so what's the trend? Okay, halogens, generally they have low melting and boiling point. So you can see, wow, negative, negative, negative. Until iodine, then it's generally higher. As you can see, that they have low melting and boiling point. Next up, you can see that they are all colored. Okay, yellow, pale yellow, greenish gas, okay, reddish brown liquid, purplish black solid. This pale yellow gas, sometimes they might say that it's colorless too, so just take note. Okay, it's not really colorless, but because it's so pale that sometimes we can't really see the color that easily. Okay, so please take note of this over here. Now, these are the physical properties. What pattern do you spot? What's the pattern? you realize that the melting and boiling point, as it goes down the group, the melting and boiling point increase. Melting point increase, the boiling point also increases. So as it goes down the group, which is the red arrow, down the group, the melting point increases, the boiling point increases. Now, how about the colors? You realize that it goes down the group, the color intensity increases. Okay, the color intensity increases. Oh man, lousy color chosen. Color intensity. Okay, the color intensity increases. From pale yellow becomes greenish yellow, become reddish brown, become purplish black. Okay, some of you might ask, then why not we talk about the gas, liquid and solid? It's like from gas it becoming solid. In actual fact, you know that it's turning from gas to solid because the melting and boiling point is increasing. So this is a result, okay, of the melting and boiling point. So the states, okay, it's a result of the melting and boiling point. So just take note of this point over here. Okay, now, can you predict the melting and boiling point as 13? What's the color at room temperature? Okay, as you can spot the pattern, melting and boiling point should increase. So 184, 300 plus, 100 plus to 300 plus. Okay, there should be an increase. Next one, okay, gas, liquid, solid. Obviously, this guy better be solid. And what else can be darker than purplish black? Black. That's all. Okay, so black solid for S13, 302 melting point, boiling point 337. So just take note of the trends. Okay, you can see we can learn to predict the melting and boiling point of substances. Next up, okay, we're going to go into the chemical properties, but let's do a summary of the physical properties. We talk about halogens. What do they have? Okay, they react with metals to form salts. They exist as diatomic covalent molecules. Not so much of an issue here, but the main thing, physical properties, must remember. They have low melting and boiling point. They are colored. And what's the pattern in this? We know that as it goes down the group, the melting and boiling point increases, while the color intensity also increases. Okay, so pale yellow, yellowish green, greenish yellow, reddish brown, purplish black. So this is a summary of the physical properties of halogen.